didn't see you there. I'm Detective Christian, certified PI. Today we're going to be looking for some sneaky angles. Angles are always sneaky. Yes. They are always sneaky, Dan. Even though they're sneaky, you can find them in the most obscure of places, such as right here. As you can see, it is almost a right angle. And so today we're going to be looking for such examples are obtuse, reflex, complementary, supplementary, and any other angles we can spot. Here you can see an obtuse angle. Well, you know that it's an obtuse because its measurement is greater than 90 degrees, yet less than 180, and 180 degrees is just a straight line. So see that big measurement? Obtuse angles can be identified by their huge measurement. An acute angle is right here. See that A at the Dance-a-thon ad? Well, see, you can identify it because it is smaller than 90 degrees, yet greater than 0. Now in the same angle, we can find a reflex angle. A reflex angle is an angle that is greater than 180 and less than 360 degrees. So here, you can see it's an invisible line, but the same acute angle has a reflex angle right there. It's kind of a circular shape. Let me just show it one more time. Right there. That's a reflex angle. But there's a straight angle hidden in this. In fact, there's actually multiple. Here's one. You can identify a straight angle not only because it's 180 degrees, but also because it's straight. It's just like a straight line segment. And there's also one here. And there's also one here. And finally there's one here. You have to kind of get low to see this one. But here it is. These are supplementary angles. Hi, supplementary angles. See, the sum of the two supplementary angles always add up to 180. So you can see it's identified by a straight line, and a line segment cuts it into two different separate angles. So you see, as this angle plus this angle always equals 180. I can tell they're kind of right angles, so it must be 90 plus 90 equals 180. Also, you can also tell because the straight line, Dad, I'm flat out. Will you supplement my allowance? I found parallel lines. The parallel lines are two lines that are like, first of all, here, these two lines are parallel. See? There and there. So parallel, when they go straight and straight and straight and never intersect, and they always go in the same direction and never go up or down. And you can identify parallel lines because they're always in like squares, rectangles, and parallelograms. While playing a game, perpendicular lines. So perpendicular lines are two line segments that intersect to form 4 right angles. That's right, 4 right angles. So if you'll come with me, here's the point where they intersect. Now, here's the line segments. There's one way right here, and the other one is right here. So now, as you can see, they form 4 right angles. One right here, one right here, one right here, and one right there. Cool. I found 2 branches of logs of a tree that happen to be skew. Now, skew lines are when these two are parallel and they're bisected by this angle. So it's kind of hard to see, but this angle and this angle are equal, and this angle and this angle are equal. And I can't believe I came across this because they're really hard to find in real life. Except for when you draw them, of course. So, this is an interesting discovery of skew line. Complementary angles are always add up to 90 degrees. We're at the upper school dean of students room, Dan Roca. So we have to be kind of quick. So these complementary angles add up to 90 degrees. Complementary angles always add up to 90 degrees. As you can see, this angle and this angle equals a 90-degree angle. It's always a right angle bisected by another line segment. And also, here's a phrase to remember it. When you do something right, you get a compliment. Today, I'm here with the plane expert, Curtis Ingraham. And he's going to teach us a little about planes.
Okay, well, we talked about planes. See, planes are about, as a teacher, I'm going to go back to Nikhil. Nikhil, a plane is how many dimensions?
2-dimensional.
Can we actually represent a plane in real life?
No.
No, but we have examples of something that's like a plane. And if we kind of turn the camera and look over at our sustainable energy source, which are what?
Solar panels.
Oh, solar panels. We could almost call those solar planes, because in fact they are two-dimensional, even though they have some width. But they're a good example of what a plane really is.
How many planes are there, Mr. Ingram?
Well, if I look at that right now, I'm seeing 1, 2, 3, 4. You got to look at that.
No, I mean in the real life.
Oh, there's infinite planes. They're cutting me up into bits right now. But if we look at all those planes there, those planes, I see 1, 2, 3, 4, 5 rows of parallel planes. Parallel planes, like parallel lines, never intersect. Okay.
Okay, thank you so much, Mr. Abraham, for your time. Search for planes. And angles, of course. And now, if you'll excuse me, I'm off to go to look for something else. Bye!